How are you all guys? Parvini, what are you doing in school, ma?
Um, we just did like solving trig equations and inequalities. We had a quiz on that today.
Oh wow, okay. Then is there any other upcoming quiz on that?
We have two formatives and a summative for this unit. They split
Oh,
the
so the
three
summative is
units
not
into
yet
two.
over. Summative
Yeah.
is not yet over on that? Oh, that's
Yeah.
good. Okay. Okay. So when are you going to start polar graphs? You
Um,
don't know?
I'm not sure.
Okay. 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 Anyway, let's go ahead. I'm going to work on trig equalities, inequalities today. But let's see. Krish, what are you doing? And Advik, what are you doing in school?
We're work we have a test on Friday over the six trig functions and then the six inverse as well.
Oh, nice. Okay, so you're okay in sync with me. That's good. Okay, okay. Dhwani should be the same. Advik, what are you doing?
I have a test on Friday over exponential functions and like sequences and stuff.
Okay, but are you using what we are learning, Advik, here?
Yeah, it's pretty easy. Yeah,
Oh,
like for
nice.
me in class, it's like they're at school is pretty easy.
Oh, that's nice. Okay, that's nice to know.
Yeah.
But yeah, sequences we didn't cover much, right, Advik?
Yeah,
Yeah.
I still understand. It's like it wasn't too hard to understand in
Yeah, yeah,
class.
yeah. Yeah, it follows from Okay, that's fine. Okay. Yeah, tell me, Madhvani, what's up?
We also like at least for my class, we have like a concept check on like having to draw all like the 12 parent graphs.
Ah, okay.
Yeah,
Okay.
same here.
Okay. You had or you're going to have, ma?
We're gonna have one tomorrow.
Okay, the parent graphs, huh?
Yeah, all the 12, like it's gonna be timed. I don't know how long, but yeah.
All the 12 na sine, cos, tan, cot, cosecant, secant. Oh, inverses, huh?
Yeah, inverses for all of the six graphs.
Okay, okay, okay.
Like I just like I can do the inverses for the sine, cosine, and tan, but I kind of have like problems like kind of memorizing the inverses for cosecant, secant, and cotangent.
one second, ma. 1 second. What did we do? Let's see. Give me a minute. Let's get that done. See, basically, we discussed sine inverse, cos inverse, tan inverse last week, right? So let's see. Oh, you have to draw cosecant inverse function, is it?
Yeah, we have to know that as well.
Ah, I see. I see.
For that, we just like they taught us just to like limit the domain, the same thing for the other inverse.
Okay, hold on. Hold on.
But it's just hard to remember.
See, that I have not even covered in class. Cosecant inverse function. Let's see. Oh, is that hard on you? Okay, cosecant inverse, secant inverse,
It's not
and
hard, but like I mean, normal problems with it is not hard, but like having to like graph it, like the parent functions is a little hard because like there are like nine other graphs I need to think about before doing it.
oh, just the parent function, right, ma?
Yeah.
Okay. Okay, let me go over the initial ones first and then we'll see how much of the cosecant, see cosecant inverse, secant inverse and cot inverse I don't even have, I have not even planned, but let's see what we can do. Okay, so this one I have not covered. Sign. Okay, I did this. Let's see quickly. Hold on. What did we do? Okay, let's review this. I'll go over that, ma. Let's see. Okay, now find the principal value. Cos inverse of minus root 2 by 2. Cos inverse of minus root 2 by 2. Cos inverse of, let me see. Are you able to do this check? Cos inverse of minus root 2 by 2. Only the principal values I need. Are you able to look through this and find what it is? In the unit circle, see which quadrant it belongs to. Cos inverse of minus root 2 by 2. So where can it belong? What are the principal values? Only the top part.
Do you put in the chat or should I just say it?
Chat is better, ma.
Oh,
So that I'll know what you guys know, right? In the meantime, cos inverse, you wanted these functions, right? Let's see. Are you able to get through this? I got some answers, but I do not know whether you all understood. Let's see. One is this. Oh, and there's one more, right? Is that right, Parvini? Okay, okay. Should there be two values or one value, Madhvani?
shouldn't there only be one? Because like cosine's in the first and second quadrant, and it's only
Good job.
negative in the second.
Yep, good job. So, Parvini, there was one correction, right, ma? So, cos, the principal value in radians is only this graph and it is negative, right? So, whatever is in here is valid, right, Parvini?
Yeah.
So, answer would be somewhere here, right? Right, ma?
Yeah.
That's the only one value that's valid. Advik, did you get that?
Yeah, I got it now.
Inverse of root 3. Let's do that. That's the only We did not do cosecant graph itself. Let's first do, oh my god, my video is not on. Guys, it's 40. Okay. Ma pi by 3 or pi by 4? Pi by 6. Oh my god. Okay, guys, I'm getting values pi by 3, pi by 4, pi by 6. Which one is correct? I really don't know. Tan inverse of root 3. Tan inverse of root 3. It's like sine, right? So for this one, what do? For this one, you choose this, right? Tan inverse of root 3. So tan inverse is positive, right? This is negative, this is positive, this is negative. So there should be only one value. This is positive, so this is positive, this is positive. So what is the answer for this one? I see a lot of different values. I'm a little worried. Okay, thanks, Krish. Lopa, do you want to check? Is it 60 degrees, ma? Dhwani, Lopa, correct, ma? Sorry. Yep. Advik, did you get it? Okay, some of you have not responded. Why? Parveen, Krish, okay, all of you. Dhwani, you got it?
Yeah, I think so. Yeah.
What is the answer, ma? Shout it out.
Pi over 3.
Yeah, pi over 3. Coming to secant 3 pi by 4, what is the value, guys? Secant 3 pi by 4. Secant 3 pi by 4. Let me put it down. We will secant 3 pi by 4. Find the value of this. But you want me to tell you whether it is in principle? Okay. Find the exact values. Find the exact values of these.
The exact value, you mean like we put it into the calculator and then?
No, not in the calculator, right? I would ask you to go ahead with 1 by cos 3 pi by 4. So cos 3 by 3 pi by 4, you'll know the value and then you can find the exact value, correct?
Oh, okay, yeah, that's how I sent it. No, okay.
Yep. Meaning this will restrict the use of calculators.
Yeah. Miss Priya, can I submit the homework like next week because I have a
Yes, DECA
competition for 3
Ma'am,
days.
absolutely, ma'am. Many of you have DECA competition. There are two, three people have not come to the class because of DECA competition. So I don't know what to do, honestly. So you do it later.
Okay, thank you.
When is the DECA competition?
It starts like tomorrow, so I have to like leave school midday, and it's until Saturday.
Oh wow. Okay.
Miss Priya,
Yeah, ma'am. Go
what
ahead.
do you mean by exact value?
Okay. 1 by cos 3 pi by 4. So what happens then? Does that make sense?
Oh, yeah.
Uh-huh.
Yeah.
Then what happens? 1 by minus root 2 by 2, correct?
Yeah.
So, but this is not your answer, right? You proceed and let me know the answer. Nice, Shragvi. Shragvi, what are you doing? Amma, Dhwani, you cannot say the answer like this, right, Dhwani? Irrational denominators, right? Krish, is that right? I don't think that's right, Krish.
Yeah, I'm doing it.
Advik, that's right.
Do you want me to rationalize and then send it to you?
Yes, absolutely, ma. Anytime,
Okay.
anywhere in mathematics, you're expected to do so. Make
Because
sense?
like in school, our teachers accept it both ways. That's why.
Oh,
I
wow.
did it that way.
Okay.
But I
Then
can
I
rationalize it.
see.
Just
As
give me.
long as your teacher accepts, I'm not bothered. But at the same time, Wherever you do, you have to rationalize your denominator and then send.
Is my answer right now?
Yeah. Uh, yeah. No, wait. Yes, Krish. See, okay. This is what I told Dhwani. See, Krish, this was the answer, right? Here there is an irrational denominator, right? Wherever, whatever you do for me, I have not accepted irrational denominators, but Dhwani says the teacher accepts. I don't mind at all if your teacher accepts.
Yeah,
So
she
what
does.
I do, I rationalize the denominator here. In that case, it becomes minus 2 root 2 by 2, right? So it becomes minus square root of 2. This is the answer. I'll accept, but I'm okay. If your teacher accepts, I'm least bothered. You see,
Okay.
then you go ahead with your teacher, I would say. So this is accepted.
Okay,
Can
thank
I move on? Okay, now let's go ahead and do the inverse functions. Yeah, so let's do the reciprocal functions. How about this? Let's graph these quick and then let's do one of the inverses. That is what you're finding it tough, right? Let's see. So this one, right? For this one, right? Let's say this is one. I'm going to put the ordinary function first, sine function first. Does that make sense here? Okay, now. Okay. So, cosecant x will be equal to 1 by sine x, right? So, literally when you think about this, let's do 1 by 1. 1 by 0 should be undefined. So, this place at 0, it should be undefined. And then 1 by 1 should be 1. So, this is a point. Here at this point it should go up because it's undefined, so it goes up like this. Again at this point it goes up like this. Again here same thing happens, right? At this point it is undefined, here it went to undefined, so at this point it goes like this, comes out like this. Similarly the same thing happens here. So cosecant x, the graph will be like this. 3 pi by 2, pi by 2. This is the asymptote. This is an asymptote. Wherever you have the 0 points, right, that becomes an asymptote because that is 1 by sine x. Any questions on this? Any questions on this? For secant x, which is 1 by cos x, this one I did not do, guys, so I don't want to skip this and go to inverse functions. Let's see one by one. For this one, the graph looks weird for this one, so all u's. When you place the u, usually when I started out, right, I always had the question, where will this u come, right? So sine function, wherever it is peak, 1 becomes a 1 in the inverse function too. So that's how I remember. I try to remember this. Now coming to cos, right? Let's go over the cos function. One second, guys. I don't want to draw the cos function directly. Let's do this. I feel like I can just cut paste it in a way. Okay, let's see this one. So first I'll draw the cos function. Okay, first I'll draw the cos function and then I'll go ahead and draw the inverse function pretty easily, because wherever 1 by cos, right? So wherever there is a 0 point, it's going to be, this is a 0 point, this is a 0 point. So those are going to be the asymptotes. So here your graph is going to go like this. Here the graph is going to go like this. This is an asymptote again. Similarly, wherever the graph here, this is going to be an asymptote, this is going to be an asymptote. So it's going to go like this. So at your x equal to 0 position, the u is going to cut symmetrically for a secant graph. So these things you would have come across already is what I'm thinking at school, so I can be a bit faster too. For the tangent graph, right? For the tangent graph, we have always drawn it this way, right? Minus pi by 2. Let's see. For a tangent graph, let me go ahead and draw it this way. So from it was going to be pi, so minus pi by 2 to pi, right? So you had always drawn it this way, right? So now for a tan inverse, right? So when I say f of x will be equal to 1 by tan x or cot x, right? So wherever there was a 0, it's going to be undefined. Wherever there is a 0, it's going to be undefined. So how do we graph it? What did I do? Sorry guys, give me a minute here. Let me paste a graph for you. I don't have a graph. So wherever there was wherever there was a 0, it's going to be undefined, right? So let me try bringing a graph here, a blank graph, and then draw based on that. Let's see this one. Yeah, this is a good one. You're going to ask if you don't understand. Shri, what are you doing in school?
We're on we have a test over 3.6 and 3.7 tomorrow.
Oh, 3.6 and 3.7. Okay. You are far behind, I feel. Okay. For a tan inverse graph, I'm going to draw it here. Okay. So here, guys, it's going to be pi by 2, and then you're going to continue here. So at 0, you're going to have an asymptote. And then at pi, you're going to have an asymptote. 2 pi, you're going to have an asymptote. Now, how is it going to come? Pi by 2 is going to be a 0. This is going to look like this. Any questions? Any questions on that? It's going to be 1 by tan x, right? So let me move on from here. Okay. Now, I would really like to do, I would like you to tell me the range and asymptotes of 3 secant x minus 1. If you want, I'll do this. The next one you can do, I feel. How about you say the range and vertical asymptote of 3 secant x minus 1. I'm going to delete all this. 3 secant x minus 1. I would like you to tell me the range and asymptotes of this. Shall we try that? Okay. In the meantime, this one if you want me to do, I can do it. 3 is the amplitude. 3 secant x minus 1. Minus 1 pushes the graph down by 1. So that becomes your midline. Minus 1 becomes your midline. Do you want to do or do you want me to do? Let me know. Where are the asymptotes going to be? Yes, go ahead, ma.
Can you do this one?
Yes, absolutely. See, this f of x equal to, this is going to be your amplitude. The secant x graph is pushed down by 1, right? Now, I want a graph, guys. Hold on. Let me see whether I can bring a graph. Yes. Let's see this graph. Okay, let me draw it there. So here, okay. Okay. Now the your secant graph, your usual secant graph is going to be pushed down by 1. Okay, so first, if I want to do a transformed secant graph, right, the first thing I would do is let me draw the midline. Midline is going to be pushed down, so midline is going to be here. Okay, so I've catered to this. Okay, but then the amplitude is 3, and I am going to mirror a secant graph. Mirroring a secant graph is honestly tough for me. So let's see 3 amplitude. First, I'll draw a cos graph. Okay, let me see. This is 1, 2, 3. So this is going to be a -1. I'm just drawing a cos graph, guys. 1, 1, 2, 3. I'm just drawing a cos. I'm just trying to draw a cos graph. Hold on. 1, 2, 1, 2, 3. Okay, then 1, 2, 3. Then again 1, 2, 3. Okay, so if I have it like this, right? No, it should be here, right? Okay, let me move it a little bit. I don't want these false points. Please let me know, guys. If you don't understand, you have to let me know. This is my graph, right? I can go to pi to 3 pi. Okay, now let me go ahead and graph the cosecant graph. If it was, I drew a cos graph and I'm going to invert it, meaning I'm going to find the reciprocal graph. So that becomes easy on me now. Here, okay, first of all, what will be the range of this graph then? Range is easy now to draw, right? What is the range of this graph? I'll go from the lowest to the highest, right? So what will be the range of this graph?
Would it
What?
be negative infinity to -5 union
Yeah,
2?
negative infinity to -4, right, ma?
Oh
Negative
yeah, sorry,
infinity
-4.
to
That's what I meant.
-4. Yeah, yeah. -4 is included or excluded. That is
Included.
usual included, because see, we include these points, right? So that is included. Union again till -4, minus infinity to -4, and then you don't have the graph till 2, but 2 is included, 2 to infinity. Any questions, guys, on that? Any questions? Now, how to find out the asymptote? Whatever dotted graph I have drawn is for the cos graph. Cos graph, wherever it crosses the midline, right? Wherever the cos graph is going to cross the midline, there you're going to have an asymptote. Does that make sense? See, that's the only easiest way, reliable way, where you will not make mistakes. So I will go ahead and draw at pi by 2. Wherever you see here, wherever I have 0, I will go ahead and draw my asymptotes. Does that make sense, guys? Where is the 0 here? Here. Any questions, guys? So the width of this, so how do I write my asymptotes? So first let me draw the graph and then draw the asymptotes. Okay, so here the first one from 0, the first is at pi by 2, and then there is an interval of pi. So okay, first let me draw the graph. When you draw the graph, what happens? It's going to be the inverse of this, right? This is my original graph. Make sense? This is my graph. Okay, the thick and red lines are my graph. However, when I want to write the vertical asymptotes, right? So first one is from 0, see where it is going, and then the width between these is n pi, right? So it will be n pi. Make sense? Now, would you like to try this one for me? 2 cosecant x minus pi by 2 plus 1. Let's see. I'm going to erase this. Any questions here, guys? First, as a person, meaning if I am asked to draw the graph, I would like to see how these changed. Okay. Then based on this, I would draw the midline, and then based on the amplitude, I'll draw the cos curve first. Okay. That is only easy for me. I can't do the secant curve directly. So cos curve I would like to draw. And then once you draw the cost curve, it's easy to draw our secant graph. Okay, then asymptotes come at all points where the cost graph is 0. Okay, now let's see this one. If you don't get it, then I'll do it. Can we do this one? F of x equal to 2 cosecant x minus pi by 2 plus 1. Can we try that, guys? And in the meantime, I want to go with what Dhwani asked. Cosecant inverse, secant inverse. What is that? Let me see.
You just want the range and asymptotes again?
I just want the range and asymptotes again, correct. Asymptotes in terms of n. Which problem did I give you? Cosecant x minus pi by 2. Okay. Not a hard one when you think about it, but let's see. Cosecant cot. When there is a phase shift, yeah, there is a phase shift, right? Okay, previously we didn't have a phase shift. Let's see. See, phase shift is a little confusing. Phase shift of pi by 2 to the right, right? Phase shift of pi by 2 to the right. Phase shift of pi by 2 to the right. Now, this is a sine graph. The phase shift, draw the sine graph, move the midline. 2 is your amplitude.
I sent you my answer.
Yes, ma'am. Range is correct, ma, but is your asymptote correct? See, there is a phase shift, right? When you did not account for that.
Yeah, I mean, what I did to do for the phase shift, I just did x minus pi over 2 equals wait, never mind. I took the wrong asymptote to begin with. Sorry.
Yeah. You did the wrong asymptote to begin with because you did not account for the phase shift.
No, I accounted for the phase shift, but I took the asymptote equation for secant and not cosecant. I did pi over 2 plus pi k instead of just pi k.
Oh, okay. Okay, and you wanted cosecant inverse. Cosecant inverse is, okay, should be doable. Let's see.
Like I understand them, I just can't memorize them and like do it in a time setting.
You just need to draw the graph, right, ma?
Yeah, but it like takes more than a few minutes to do all three, and it's fine.
Okay.
I was like trying to figure out a way to like memorize these 3.
Okay, I see. But sine inverse is easy for you, right?
Yeah, that stuff's pretty much easy.
See, cos inverse and the secant inverse. Let's see, let's try to memorize it now. Should be doable, I feel. But just the parent graph, right? They don't discuss transformations of cosecant inverse, secant inverse, and cot inverse, right, ma?
No, not just the parent graph.
That's just the parent graph. Okay, I'll just go over that quickly. let's see how to go. Okay, did you guys get it? Yeah, ma. Krishiv, did you get it? Lopa, you leave, ma,
I'm
if you
doing it.
want. I okay. Okay, I'll help you with it, ma. Just to memorize. Raw way of memorizing is not hard, I feel, with respect to your inverses. Let's see. Cot inverse is a little bit different. Anyway, we'll
Miss
do
Priya, can you
some.
check my answer?
Yes, ma. Yes, Shri. Shri, we are working on range and for this graph, right? Range, and I just want you to tell me the vertical asymptotes, right, Shri?
Oh, okay.
Shragvi, are you able to understand or you need help?
Yeah, I'm gonna send you my answer.
Uh-huh. Dhwani, you're able to plot the sine inverse, cos inverse, and tan inverse, right, ma?
Yeah. It's
Okay.
only like the three graphs, the inverses of the reciprocals that like I
Okay.
can plot them, but it takes me way too long.
Oh, no, 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 no. Okay, we'll
Yeah.
do that. We'll do that. I can help you with a raw way of under meaning, making sense and doing it quickly. Let's see. Is infinity to 1 and 3? Yeah. Advika, I'm checking. Yes. Uh, how to write the asymptotes? Did you get the asymptotes? Pi by 2. Okay, that's right, Krish. Okay. Okay, how about this? Can you tell me just the asymptote? Can you tell me just the asymptote for this third function? Whoever has completed that, right? Can you tell me just the asymptote of the third function? This is number 2 we did. This is number 3. Just the vertical asymptote of this function. How do you do it? It's shifted by cot, right? Just the asymptotes, how do you do it? Not a hard one, but you can let me know how do you, if you want, I can meaning I can show you the asymptotes of the third one, but let me know, guys, if you are able to find the equations for it. If you don't know, I'll help you. Here, second one, cosecant graph, but the cosecant graph, the problem is it shifted. First of all, it's up one, okay, it's up one, and then the amplitude is 2, but it is shifted to pi by 2 to the right. So what happens? The 0 points get shifted by pi by 2, right? So the amplitude is 2, so it goes till 3. It gets shifted by pi by 2 to the right? So the sine graph becomes like this. So how did you draw the graph here? What did I ask you? Range, right? Krish, are you able to do the third one, Krish?
Yeah, I just sent.
Okay, I didn't see. Let me see. So the final graph for this one would be, see, wherever there is a zero, there's going to be an asymptote. Wherever there is a zero, there's going to be an asymptote. So the graph is going to look like this. Okay, wherever there is a zero, there's going to be an asymptote. So the graph is going to look like this. Wherever there is a zero, there is, okay, we don't need to show here. So the graph is going to, the thickened ones are our graph. Shragvi, are you following?
Yes.
Okay, cool. Okay. So here, when you think about it, it's 2 down, minus 1, right? Minus infinity to minus 1. Minus 1 is included. Please, when it comes to cosecant chord graphs, you have to make sure you include the minus 1, and then here 3 is included. So, and when it comes to the vertical asymptote, it's clear. So first write the first one, pi by 2, and then what is the distance. So that you include. Pi by 2 is your first one, and after that pi is the distance, correct? Pi is the distance, so pi n, pi k or pi n. Okay, for this one, are you able to tell me the asymptotes only? You will know the range. You can find the range by yourself. Can you tell me for the third one? I just want to know the asymptotes. Vertical asymptotes happen at 2 plus pi by 2. I think pi by 2. Is that right, Advik? The first asymptote happens where? That seems incorrect, Advik.
Wait, me? For which one? I only sent my range for the last one. I haven't done this one yet.
Okay. I just need the asymptote. Asymptote needs, it's a little bit tricky, I feel. I would draw the tan curve and then draw it. See, for tan and cot, okay. The problem is that 2 is going to wreak havoc. The horizontal 2, meaning this 2 is going to wreak havoc, right? Because of this 2, you cannot say pi n, right? It's like tan b theta, cot b theta, right? So the asymptotes are going to be at every interval of pi by 2, not pi. This 2 gets divided, right? Dhwani, Krish, are you able to write the asymptotes for the last one? Cot.
Yeah.
Parvini, same problem, Parvini. It's not pi, right? It's not pi, right? Tan and cot, yes, I understand. The period is pi, but here because of the 2, it becomes pi by 2, right, ma? So the asymptotes will be at an interval of pi by 2, right, Parvini?
Yeah.
Does that make sense, Parvini?
Yeah.
Okay.
It's because it's cotangent, right?
Cot and tan both have a period of pi, no doubt, ma. But then, because of the 2 here, it becomes pi by b, right? Does that sound good?
Yeah.
For tan b theta, it becomes pi by b, right? So here 2 is the b value. So in that case, it becomes pi by 2. So for every occurrence of pi by 2, you will have the make sense, huh?
Yeah.
It is going to be like this, right? Dhwani, Krish, Shri, did you get it?
Yeah.
Pi
Yeah.
by 2, okay. Yep. Can I move on? Okay, now to draw the cos inverse, secant inverse, I can do it quickly. Let's see. We want to draw, meaning, see guys, I don't, usually I don't cover this at all. Okay, how to write out the cosecant inverse of x, secant inverse of x, just the parent graph. Usually I don't cover because only the parent graph, nothing much or transformation will be covered as a part of this, so I don't even show this. Dhwani has asked, right? So let's go ahead with that. Let's consider these. Okay, how to draw it quickly. My easiest way is see, I have sine inverse here for cosecant inverse, cos inverse here. So for me, I would have this point permanent, meaning wherever there is a 1, right, that is permanent. Sine inverse graph, first it's easy to draw the sine inverse graph. Right, after that these 2 points are permanent and then extend it the other way. That's it, meaning wherever there is a 0, that is going to become an asymptote for the cosecant inverse function. What I'm saying is here let me erase everything. I'm going to draw for cosecant inverse in this. First you will draw the sine inverse function. Okay, these 2 points are going to be constants because they are not going to change. So 1 by sine inverse of x, right? So sine inverse of x, if it is going to be pi by 2, it's going to remain as 1. It's just going to be the opposite, right, for cosecant inverse. So those 2 points are going to remain constant. Put dots there. And wherever there is a 0, 1 by 0 becomes undefined, right? So that's going to be an asymptote. So clearly from there extend it and point towards the asymptote. Clearly from here point towards the asymptote. Does that make sense, Ma, Dhwani?
Okay, so whatever like the zeros for the inverse of sine or cosine is, it becomes the asymptote for the inverse of cosecant and secant.
Yep. So that's easy. So sine inverse function, you're saying it's very easy for you to draw. That we will remember, right? That we already drew as a part of the class and in school you would have drawn. This is very easy to draw. But remember, this one will be thetas, this one will be values. You know that, right?
Yeah.
Now, for drawing the cosecant graph, there are only 3 points. Reference points are only these 3. Okay, these 2 are never going to change because sine inverse 1 by sine inverse of x, right? Sine inverse of x is a 1, it's never going to change. Those points are going to remain constant, have them there. But if it is a 0, that becomes an asymptote. So this becomes an asymptote for my cosecant graph. So from there, go towards the asymptote. Make sense?
Yeah.
Does that make things easy for you?
Yeah, this gives me like I can just use my graphs I drew before as a reference to do
Yes,
this.
and then put these 2 points in there. They're never going to, same thing here. They are never going to change. You see what I mean? But this
Yeah.
one is going to become an asymptote. You see what I mean, huh?
Yeah, and I know the cotangent inverse, like it's just the opposite again of the cube root. It's just not
Oh, there okay. Yeah. So see, for cos, what do you do? Again, 0 is going to become your asymptote. This is never going to, meaning these 2 are very easy for me usually, but the cot inverse, I find it difficult. So here when you look at it, right, these 2 points are going to remain the same. Okay, but then you have to move towards your asymptote on both the sides. Make sense, Ma?
Yeah, I understand it now.
Yeah, cos inverse, sine inverse is very easy. But tan inverse, I don't know whether, tan inverse, from tan inverse, drawing cot inverse, I don't know, Ma. Let's see. Meaning,
Easy because like it's just
I
like the
said,
asymptote changes and it becomes the negative of the cube root now.
if it is, but see, the range also changes, right? You'll have to remember that.
Yeah,
Cot,
because the asymptote, horizontal asymptote changes, that's why the range changes.
correct. So, for cot inverse, what do you do? Okay, let's see. For cot inverse, you have to go from 0 to pi. You're clear with that, huh?
Yeah, that
Cot
cotangent,
inverse.
the tangent, I do understand that one better than the cosecant.
Oh, that's nice. That's nice. See, for cot inverse, let's try to identify the cot inverse of x graph. For that one, yes, the same logic applies, okay, but then wherever there are asymptotes, you are going to have values, but then it's going to shift up by pi by 2. That's the only thing you need to remember. This is 1 by tan inverse, right? So wherever there is a 0, it's going to become an asymptote. That's why it changes. So this becomes an asymptote. Okay, now
Yeah.
it's going to be the opposite. It's going to be like this. Make sense?
Yeah.
Yep, this is the only thing which might be a little tricky because it's not from minus pi by 2 to pi by 2, but from 0 to pi. Cot inverse graph, the principal values become 0. This is 0 to pi, because 0 to pi, because wherever there is 0, it's going to be an asymptote. So this becomes an asymptote for you. As a result, tan it's going to be the opposite. When it is reflected on the xy plane, what this graph becomes, this becomes this. Make sense?
Yeah.
Okay, so but honestly, they won't go into depth of secant inverse, cosecant inverse, and cot inverse graphs. They may not go. Okay, now
Okay.
I would like to move
Wait.
on to. Does
Miss
that
Priya?
help you? Yeah, ma.
Yeah, it does. Can I leave now?
Yeah. Please, you told me. Okay.
Thank you, Miss Priya. Bye.
Yeah, ma. Bye. Okay, now I really want to go ahead with the uh, trig functions. One second, guys. Okay, now, okay, in a unit circle, let me go to the unit circle. Let me go to the unit circle. I'm going to go ahead with Pythagorean identities. Okay, we'll discuss trig identities, trigonometric identities. Okay, let me go ahead with this. What did I want to show you? Yeah, the unit circle comes here. Now I'm going to have the point x comma y. This x comma y is cos comma sine. You're all aware of it. Now see this one. This one is my x value. This one is my y value. Any questions there? Now instead of that x and y, I can say, hey, this is my cos value. This is the unit circle, remember? This is the cos value. This is the sine value, right? So you know that x square plus y square equal to 1 is the equation for a circle with origin as the center, correct? Now x square, if I replace it by cos square x, y square if I replace it by sine square x, we get a very important identity in trigonometry, and that is cos square x plus sine square x equal to 1. Any questions? You can as well write this out as cos square x equal to 1 minus sine square x, or you can write it out as sine square x equal to 1 minus cos square x. So these these are called Pythagorean identities. There are so many identities in trigonometry. In honors pre-calc, it was really very extensive. Identity. Uh, in honors pre-calc, it was much harder. Now they have made it very easy for you in AP pre-calc. Okay, only a few are getting covered, which is good for you. So, which is good for you and bad for your mathematical base though. So, cos square x plus sine square x equal to 1 is the Pythagorean identity. Any questions on that? Any questions on how you got it? Okay, now can I move on? When it comes to, okay, now that we discussed Pythagorean identities, right, we have to discuss reciprocal Pythagorean identities. Let me show you what are they. We have okay, so we have Pythagorean, let me put it down separately so you know. Pythagorean identity, I'll put it in here. X square plus y square will be equal to 1. That was the base. But we had cos square x plus sine square x equal to 1. Or we could have said cos square x equal to 1 minus sine square x. Or sine square x will be equal to 1 minus cos square x. Parvini, what identities they have covered till now? All are covered, huh?
They didn't go over anything like this.
Oh, you are solving trigonometric equations, huh?
Yeah.
Oh, I see, I see, I see. I'll just go over this and then also cover that. Let's see. Now, here I want to do reciprocal Pythagorean identities. Reciprocal Pythagorean identities. Here, what we do, we take the base cos square x plus sin square x equal to 1. We take that base. We do two things. Okay, we have to derive two different things, meaning we have to derive two different identities here. So first you divide by cos square x. You divide by cos square x everywhere. So what happens? Now again the same Pythagorean identity, please take it, and then you divide by sin square x. Sin square x. What happens, guys? You get into two different identities which are called reciprocal Pythagorean identities. 1 plus tan square x equal to secant square x. Any questions on this? The other one says, what is this? This is cot square x plus 1 will be equal to cosecant square x. Any questions, guys? Any questions on this? Any questions on this? Okay. Now we studied Pythagorean identities and reciprocal Pythagorean identities, right? Now we can use this to simplify expressions very easily, meaning they give you some trigonometric expressions. You can use these identities to simplify values. Let's say they give you tan x cos x. If they say, hey, simplify tan x cos x, they ask you this. See, tan x, this can be written as sin x by cos x times cos x. So this can be simplified to sin x. Any questions on there? Now I'm going to ask you to simplify a couple more. 1 minus cos square x by cos square x. 1 minus cos square x by cos square x. Do you want to try or do you want me to try, guys? It's pretty easy, right? Meaning simple ones I'm discussing now. So can we try these two, or you can as well try cos square x plus sin square x by sin x secant x. Cos square x plus sin square x by 1 minus or plus 1 sin x secant x. Okay, let's do this. Sin x secant x. I'm discussing the very basic sin x secant x. You're going to simplify these two and tell me the final answer for these two questions. Simplify using Pythagorean identities that we discussed. Did you get it? Did you get it, or do you have questions? I don't know, guys. You have to let me know. Lopa, did you want to log off today early?
Oh, my meeting's at 9:05, so I can just leave at 9.
Okay.
Thank you.
We'll do two more simple problems on solving trig equations, and then I'll see. Yeah, we did not do something before, so let me see that. Tangent we did the graphs, but we did not do solving or finding inverses and graphing. Let's see. Oh, that we did not discuss. Okay. Let me try doing this as well. Find the inverse of the function. I want to do this one. We'll do this, guys. Done? Did you guys get it or you're waiting? You're just going, that's right, ma. That's right on the first one. Second one you want to do, Shragvi? Krish, did you get the first one?
Almost.
If you have, if you have not, Pythagorean identities are sine square x plus cos square x equal to 1 in a unit circle, right? So now this can be rewritten as sine square x equal to, these things you'll have to memorize, there's no other go, equal to 1 minus sine square x. Reciprocal ones are divide by cos square x everywhere. So divide by cos square x everywhere, you get tan square x equal to 1 minus okay, divide by sine square x first. Let me see. So you get 1 will be equal to cosecant square x minus tan square x. So that gets you to cosecant square x is equal to 1 plus tan square x. Similarly, you will have secant square x equal to 1 plus cos square x. You will memorize the boxes. So use that to simplify this. Are you getting that? I'm checking. That seems right, ma. Shragvi, you already learned this in school, huh?
Yeah, we're doing it right now.
Okay, Advik, correct. Krish, did you get it? Lopa, Shri, did you get it?
I'm a little confused.
Kind of.
Okay, I can help Krish. 1 minus cos square x is what, Krish, here? See, 1 minus cos square x is clearly
Sin.
what? Yep, sine square x. Make sense?
Yeah.
By cos square x, which becomes tan square x. That's it.
Okay.
Similarly, this one, right? See, this one is the culprit. I don't want to have it like this. What is that? So now, first of all, cos square x plus sine square x, there is a direct identity, right? 1 by sine x secant x. But secant x can be written as what? 1 by sine x times 1 by cos x, right? Now, this becomes 1 by tan x. That can be written as cot x. Make sense?
Yeah.
Shri, did you understand these?
Yeah.
Shri,
Oh, yeah. I kind of get it. Yeah.
Pythagorean, wait. I am not happy. Identities.
Miss Priya, can you hear me?
Yeah, to an extent.
Oh, okay.
1 minute. Okay, so you are going to do 1 or 2 more on this, please. Okay. How about this? Can you simplify this one? Let's see this one. How about this one? Is this easy? Let's see. I'm going to erase all of this. Come what may, whatever given, you should be able to simplify just using Pythagorean identity. I'm not moving on to other identities at all. So can we try this one? Did you get it or do you want me to solve? Quickly tell me, guys. For me, anything is okay. Did you get it? Krish, are you able to proceed with that?
I think so. I'm working on it.
Okay, nice. It's just LCM. Again, it just involves a plus b the whole square, all that stuff. Sine square theta plus 1 plus cos square theta plus 2 cos theta divided by what to do? This and this becomes 1, right? This becomes 1 plus cos theta and then a sine theta. Let's see what I get. I don't know. Okay, so this is 2 plus 2 cos theta divided by 1 plus cos theta sine theta. I'm only discussing the very basics. We'll see next week, okay? These are, initially it's tough, but once you get used to it, it's very easy. Cos theta sine theta. Yeah, Advik, but then you can see 2 by sine theta can be written as 2 cosecant theta, right, ma?
Oh yeah.
Yeah, initially it's a little tricky, but once you get the hang of it, it's very easy. Can I move on? Okay, let's see one more. I don't know whether we can see one more. Okay, you want to try this one? Yeah, we can try this one, and then a couple of things I want to discuss with you before we get out of this class. Let's see. Tan square theta. So this one, a plus b, a minus b formula for the LCM. Parvini, you are able to follow, ma? I didn't get your answers though.
I'm just a little confused.
Confused? Where are you confused? Then tell me.
The process is a little confusing.
Seema, okay. This is a plus b, a minus b. What is the formula? A plus b, a minus b. You have to take LCM, right?
Yeah.
You have to put it in the common denominator, right? Right? This is your common denominator, right?
Yeah.
This is your common denominator, right? So this one, this entire thing, numerator and denominator should be multiplied by what? Tan theta times what?
Which one? Tan theta times
Tan square theta times?
secant theta minus 1.
Correct. Secant theta minus 1. Then this side what should I do? Just copy the plus. Tan square theta should be multiplied with secant theta plus 1. Make sense? Now this is a plus b, a minus b formula. What you do? A square minus b square. Correct?
Yeah, just
Up will be tan square theta secant theta minus tan square theta plus tan square theta secant theta plus tan square theta. This and this gets cancelled. I'm just multiplying, distribution. Make sense?
yeah.
Now this becomes 2 tan square theta secant theta. Make sense? Divided by, what is secant square theta minus 1 in trigonometric identity? Secant square and cosecant square will be 1 plus tan and cot, right? So here cosecant square theta minus 1 will become what? Secant square theta minus 1 is what? Okay, let me write out. See guys, you will have to memorize this, okay? It takes time though. Now secant square theta will be equal to, which is always 1 minus tan square theta. Okay, cosecant square theta will be equal to 1 minus cot square theta. Here you have secant square theta minus 1. You'll have to manipulate it a little bit. So secant square theta minus 1 will become what? Tell me
Negative
that.
tan squared theta.
Yeah. So secant square theta minus 1 will become tan square theta. 1 minute, 1 plus. Okay, wait. These both are plus. Sorry, I wrote it wrong. So here, what did I do? Okay, tan square theta, secant theta. Yeah, secant square theta minus 1 will become tan square theta. Now tan square and tan square will get cancelled. The answer is 2 secant theta. Any questions?
No.
Okay, but we'll discuss a lot more in depth next week. I really wanted to see whether we are able to do state, domain, and range for the inverse function. Let's see this one. Using the identities, we are going to try this. Using trigonometric identities, we are going to work out this problem. Okay, meaning we are going to use a, okay, 1 is equal to secant square x plus tan x. 1 is equal to secant square x plus tan x. See, we are going to solve the trigonometric equations, right? Then that means what? We are going to find the x values, exact x values. Okay, they have given a restriction, 0 to 2 pi only you are going to look at. So what can we do? Using trigonometric identities, we have to solve this and find out the value of x. For that, what you can do, you have tan x in here clearly. Okay, but you have a secant square x, and Pythagorean identity is the best to use because secant square x can be converted to tan, right? So secant square x will be equal to 1 plus tan square x that we know. So I will change it to 1 plus tan square x plus tan x. See, we are getting it in a quadratic. See, x square, x term, you see meaning here. Now 1 plus tan square x plus tan x is there. What I can do about this, can I take, can I subtract, see there is a 1 occurring on both sides, so this will be equal to 0 equal to tan square x plus tan x. Now can I take tan x common? See, please, okay, if I take tan x common, this becomes tan x plus 1. So by the product property, right, you can say tan x equal to 0 or tan x plus 1 equal to 0. Here tan x will be equal to minus 1. Here tan x will be equal to 0. Now go back to your unit circle and tell me where this is 1 comma 0, this is 0 comma 1, 0 comma minus 1, this is minus 1 comma 0. Where tan x equal to 0, guys, you are going to tell me where tan x is going to be 0. You have the restriction as well. Between 0 to pi, you will have to tell me the values. Where tan x will be equal to 0, wherever sin x is 0, right? So what are the values for tan x equal to 0? Anybody? Guys, you are going to tell me, please. What are the values where tan x equal to 0? Tan x is sin x by cos x, right? So wherever sin x is 0, those are the values where tan x is 0. So where sin x is 0? Krish, do you want to call it out?
Um,
I'm asking tan x should be 0. For tan x to be 0, sin x should be 0. All these are cos comma sin, cos comma sin. So what are the possible values where sin x is 0, I'm asking?
at 0 and pi.
Yeah, 0 and pi, but see, the restriction 2 pi and 0 are included. So 0, pi, 2 pi. Where tan x is a minus 1. Both sin x and cos x should be should be a 1, meaning it is a minus 1, it's not a plus 1. So it has to be a minus 1 means, see, this is going to be plus plus. Here it's a plus plus quadrant. This is cos sin, right? Here it is a minus plus quadrant, cos sin. Here it is a minus minus quadrant, cos sin. Here it is a plus minus quadrant, cos sin. Now tan x is negative in which quadrant? Tan x is negative in these two quadrants, right? Now what are the values for tan x to be equal to minus 1? Anybody, please?
3 pi over 4
And
7 pi over 4.
yep, 3 pi over 4 and 7 pi over 4. Those are the values. So the possible x values are all of this. Make sense? So this is in the range 0 to 2 pi. Make sense? Okay, I really want to see one more. Okay.
Miss Priya,
Yeah, ma.
can I leave for my meeting?
Yes, you can go, ma. So I'm
Thank
going to
you.
finish this now. Yeah, we'll do one more problem and I'll let you go. How about 1 minus, okay, try this one. This is an easy one. 1 minus sine square x plus cos square x equal to 2. 1 minus, this is an easy one. 1 minus sine square x plus cos square x equal to 2. Can we try this one, guys? By yourself. See, this gives you a clue. What can you substitute in here? Parvini, would you be able to say?
Cos square.
Yep, cos square x plus cos square x equal to 2. See, it's getting simplified. 2 cos square x equal to 2. Now, cos square x equal to 1. Take square root, cos x equal to plus or minus 1. So, where is cos x plus or minus 1? Where is cos x plus or minus 1? Any thoughts? Any thoughts where cos x is plus or minus 1? This is cos, this is sine.
Pi over
Cos,
2 is 3 pi over 2.
something feels wrong to me. Cos x is plus or minus 1. X will be equal to cos inverse of 1. Go ahead, ma.
Wait, is it pi over 2, 3 pi over 2?
Yeah, that's what. Pi over 2 and
3 pi over 2.
cos sine. Okay. Yeah, that's true. Yep. Pi over 2 and 3 pi over 2. There is a mistake there. Okay, let's see. Pi over 2 and 3 pi over 2. Any questions, guys? Any questions? So this is how you solve the trig equations given a restriction. Within this restricted values, you need to find out the possible values of x. But we have discussed just Pythagorean identity and reciprocal Pythagorean identities. Okay, there are more identities. What are the other identities that we have? Meaning at least what we are going to cover, right? We will cover double angle identities. We will cover double angle identities, and then we'll also cover difference identities. So this two we'll cover next week. Identities. Okay, these two we'll cover next week. Difference of angles identities and double angle identities we'll cover next week and solve problems using that. Also, we will do some inverse trig equations. Find the inverse of trig functions. That we'll do it next week. If you have any questions, you stay. Otherwise, we can log off now. Let
Thank
me
you.
know. Yeah, guys.
Thank you, Miss Priya.
Miss Priya, thank
Bye.
you.